Okay, friends, I have already started coaching you a topic called permutation and combination. I would like to repeat that this is a beginning of a science of mathematics called combinatorics. And it starts with two fundamental principles that they are called fundamental principles of counting. We all think that we know how to count, but I can prove it that you do not know how to count, right? And those counting principles, last time I introduced, are two principles. Number one, multiplication principle, and number two, addition principle. What is multiplication principle? If job A can be done in m ways and if job B can be done in n ways, then if I want to do both the jobs simultaneously, then I will have to multiply m into n. So total number of ways of doing two jobs A and B simultaneously is A multiplied by n. And there was another principle called addition principle. Addition principle means job A can be done in m ways and job B can be done in n ways. Then either of the two jobs, not two jobs simultaneously, only one of them can be done in how many ways? That is m plus n ways. As an example of that, I also gave you that suppose there is a class A, there is a class A which contains 4 boys and class B which contains 3 boys. If I ask you, go and select one student from A and one student from B, then it can be done into 4 multiplied by 3. There will be 12 ways of choosing a pair of students, one from class A, one from class B. But if I ask you, go and select only one student from either of the two classes, then your answer will be 4 plus 3. So either this job or this job, then you will use or, and will be connected with multiplication, right? Now this principle need not be confined to only two jobs. There could be multiple of jobs. If there are n number of jobs, you have to multiply n number of times, okay? So let us take some concrete examples from your book of NCERT, right? So I am going to follow NCERT book and I will solve all the exercises which are given in this NCERT book. Now the first exercise that I have seen and the first 6.1 exercise and the 6.1 exercise has a first problem. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5? Assuming that there are two conditions. Number one, repetition of the digit is allowed and repetition of the digit is not allowed. Now let us understand how many digit numbers are to be formed. That means I want to have a 3-digit number. So suppose this is one particular box and this is second particular box and this is a third box. So the job is to fill up these 3 boxes simultaneously. This is the first digit, second digit and third digit, okay? So there are 3 digits to be chosen. Therefore, there are 3 jobs, job A, job B, job 3. Now, I want to find out, this is job A, selecting 1 digit, job B, selecting second digit, job C, selecting third digit, okay? Now, for filling up the first box, how many alternatives I have? I have exactly 1, 2, 3, 4, 5. So I have got 5 alternatives. So I can pick up any number from these 5 and put it here. So this job can be performed in exactly 5 ways. Now, the next job B can be performed in how many ways depends upon whether the repetition is allowed or not allowed. Now let us talk about repetition is allowed. So let us solve only this problem. Repetition is allowed. Repetition is allowed means what? Any number which goes here can come here also, right? So there are all 5 candidates available for selection here. So this is 5. Again, repetition is allowed. So any one of them has gone here can be repeated here also. So there are 5 alternatives for filling up third box. So each job can be performed in 5 ways. Therefore, the total number of ways of doing the job where repetition is allowed is 5 multiplied by 5 multiplied by 5, which is equal to 125 ways. Now, I want you to understand again that here repetition was allowed. So every job or every box can be filled with 5 numbers because every number is allowed here as well as here as well as here. So all the alternatives were 5 and multiply them together because multiplication principle, because all the 3 digits are to be filled simultaneously. So A and B and C, this job has to be done. So that can be done in 125 ways. Now, second question is what? Second question is slightly different, but the job remains same. There are three jobs to be performed. Three jobs to be performed. That means filling up these three boxes. Now, here repetition is not allowed. Repetition not allowed. That's a crucial decision. That means for first box, you can pick up any one of them. So there are 5 alternatives for the first box. But the number that you have chosen for the first box is now not available for the second box. That means out of 5, only 4 are left. So therefore, this job can be done in 4 ways. Now, out of 5, 2 digits are gone. So for third, we have got only 3 digits left. So therefore, it can be performed in 3 ways. Therefore, the answer to this question is 5 multiplied by 4 multiplied by 3, which is equal to 60. So if repetition is allowed, then 125. Repetition is not allowed, then 16. These are the answers to the questions. Okay, friends. Now from the same exercise, 6.1 on permutation and combination, let us look at the second problem that they have asked. The second problem reads like this. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated? If the digits can be repeated, okay? So now again, I want to remind you that how many digits are to be formed? 3-digit numbers have to be formed. So 3-digit numbers means there are 3 jobs to be done. So there are 3 jobs to be done. Each job is equivalent to filling up 1 box. So 1 box is to be filled, second box is to be filled, and third box is to be filled. Okay. So there are 3 boxes to be filled. That is how you will get 3-digit number. Now we have to find out how many alternatives we have for completing this job. So this is job A, selecting first digit, job B, selecting second digit, job C, selecting third digit. But you have to remember one thing, that they have written even, right? So you want the number to be even. All of you must be knowing that if you want the number to be even, then the last digit, that is a unit place, must be divisible by 2. Correct? Divisible by 2 means it should be an even number only. So how many even numbers we have here? So even numbers are 2, 4 and 6. So there are 3 even numbers available, right? So, and last place cannot be filled by any other number apart from these 3 numbers. So we know that the job C can be performed only in 3 ways, because only these 3 digits can come here. Okay. So job C can be done in 3 ways. Now, how many ways job A can be done? How many alternatives I have? I have got 6 alternatives. Can the repetition is allowed because one of these 3 will be used here, but even that can be used here because repetition is allowed. Repetition is allowed. That means all 6 numbers can be fitted here. So they fit the job. So therefore 6 ways of filling this box. Even here also there are 6 ways of doing the job. Therefore the answer by using multiplication principle is 6 multiplied by 6 multiplied by 3, that is 36 multiplied by 3, which is equal to 8, and 9, that is 110 ways of completing the job. So 110 ways. That means these many numbers can be formed, which are even in number, correct? And only 3-digit. Okay, that's all. Okay, friends, continuing with our exercise 6.1, problem number 3. Now here again, we have how many 4-letter code can be formed by using the first 10 letters of the English alphabet if no letter can be repeated. Let us understand the question properly. How many letter code? 4-letter code is to be formed. 4-letter code is to be formed means we have to do 4 jobs simultaneously. So 4 means, as I said earlier, there are 4 boxes to be filled. There are 4 boxes to be filled. 1 box for each letter. Okay. Now, how many letters are available for filling up these boxes? It is very clear that first 10 alphabets of English are allowed. Okay. Whichever we are not interested. We are only interested in numbers, right? So 10 alphabets are allowed to be chosen. So from that we can choose any one of them. So let us say And if no letter can be repeated, that is very important. Repetition is not allowed. The letter which is used once cannot be used again. So for the first letter to be chosen, we have got all 10 letters available. So here we don't have any hesitation in putting any letter. So there are 10 letters available for filling of the first box. Second letter, because one letter is gone here and repetition is not allowed, then there are 9. Now here repetition is not allowed, so there are 8. Repetition is not allowed, therefore there are 7. So first job can be done in 10 ways, second job can be done in 9 ways, third job can be done in 8 ways, and last job can be done in 7 ways. And by using multiplication principle, why? Because all these jobs are to be done simultaneously. So the answer will be 10 multiplied by 9 multiplied by 8 multiplied by 7, which turns out to be 90 multiplied by what? 56, correct? So that means 0. So exactly speaking, there are 5 0, 4 0. So 10 multiplied by 9 multiplied by 8 multiplied by 7 is equal to 90 multiplied by 56. If you multiply, the result turns out to be 5 0, 4 0. These many words or codes, these many codes can be formed. That is the answer. So 5040 is the answer for this next question. Okay. Have you understood? Fine. If you are not understood, please post your questions in the comment section. Okay. Fine. So now students, let us focus on the next problem in the same section. Now the next problem is what? Find how many 5-digit telephone numbers can be constructed using digits from 0 to 9 if each number starts with 67 and no digit appears more than once. Okay. Now let us decode this problem. How many 5-digit telephone numbers? So how many digits are used for this telephone number? 5 digits. That means one thing is clear. There are 5 jobs to be done, which means 5 boxes are to be filled. Okay. So there are 5 boxes to be filled. Box 1, box 2, box 3, box 4, box 5. So this is 5-digit telephone number. Now they have already said that a number will always start with 67. That means first digit is going to be 6. You have no alternative for that. This is the only thing which can go here. The second digit is already chosen to be what? 7. There is no other alternative. So first the 2 digits are already fixed. So we have a freedom of choosing only 3 more digits. And those 3 more digits can be chosen out of this 0 to 9. So 0 to 9 means from 0, 1, 2, 3, 4, like that. So there are 10 numbers, 10 digits available here. So 10 digits available, but no digit appears more than once. 6 has already appeared, 7 has already appeared. So out of 0 to 9, 2 digits are already gone. That means we are now having only 8 digits for filling up the third place. So here only 8 digits are available, 3 digits are gone. So 7 digits are available. Now 4 digits are gone, 6 digits are available. Therefore, these all are to be done simultaneously because we want to create a 5-digit telephone number starting with 67 and no digit is repeated here. Therefore, the answer by multiplication principle is 6 multiplied by 7 multiplied by 8 multiplied by 7 multiplied by 6. Correct? So, which means this is going to be 6 into 6, that is 36, 7 into 7, that is 49, multiplied by 8. Okay. Now, that answer is going to be 36 multiplied by, okay. So, 36 multiplied by 392. Now, that will be 36 multiplied by 392. I will calculate here. 392 multiplied by 36. My old method of calculation is this. So the answer, if you find out the product, it's equal to what? 1, 4, 1, 1, 2. Okay. So this is how the problem. I will verify the answers again. There is 0. I think it's correct. Okay, fine. Now, let us, student, look at the fifth problem. Fifth problem is like this. A coin is tossed. That means you take a coin and you toss it. How many times it is tossed? 3 times. And the outcomes are recorded. How many possible outcomes are there? A coin is tossed. When you toss a coin, there are only 2 alternatives. Either head or tail, or king or scale, whatever, right? So there are only 2 alternatives. That means 1 coin is tossed. That means the first job is done. First job is done, and that is a tossing 1 coin, then tossing a second coin, then tossing a third coin. So there are 3 coins to be tossed, and each coin can be tossed in 2 ways. So this can be done in 2 ways, this can be done in 2 ways, this can be done in 2 ways, and all the outcomes are to be done simultaneously. So therefore, the problem is simple. 2 multiplied by 2 multiplied by 2. The answer is 8 possible outcomes. Okay, that's the answer of this problem. It's very simple. Okay. Now, let us go to the next problem. Okay. Given 5 flags of different colors, how many different signals can be generated if each signal requires the use of 2 flags, one below the other? Okay. So given 5 flags of different colors, okay, how many different signals can be generated if each signal requires the use of 2 flags, one below the other? That means there is 1 flag here like this, 1 flag, and there is another flag down. Okay. So each signal is requiring 2 flags at a time. Okay. Now 5 flags are there, and how many different signals can be generated if each signal requires only use of 2 flags? So now, first, the word here is different signals. Okay. So therefore, you can see each signal requires use of 2 flags. Now, first flags can be chosen in how many ways? 5 different ways. Okay. Now, second flag can be chosen in how many ways? They have not said that the 2 flags are the flags of different colors. That means the flags, the color which is used in the first flag is not allowed in the second flag. So second flag can be filled in how many ways? 4 ways. So there are 5 ways of filling of the first flag and 4 ways of filling up the second flag, and therefore the total number of signals that can be generated is 5 multiplied by 4, which is equal to what? 20. 20 is the answer. Okay, that is the answer to the 6th question. Okay, so we have completed exercise number 6.1, and the 6.1 exercise was only based on very simple principle, addition and multiplication. In fact, we have not used addition principle at all. We have only used a multiplication principle in solving the problem. So we have just identified how many jobs are to be done. We also identified how many ways each job can be done, and if the jobs are to be done simultaneously or not. If it is yes, then we multiplied the answers. That is the way we have solved these problems. Okay. Thank you very much.